In this video, we're going to talk a little bit about the relationship between continuity and differentiability. Differentiability meaning the ability to find a derivative of a graph at a particular point or across a particular interval. You may have noticed as we've been talking about continuity that it sounds a lot like the requirements for a derivative of a function existing. And there is a relationship between continuity and differentiability. And here's what that relationship looks like. If the derivative of a function exists at a point, so if you can actually find a derivative of a function at a particular point, the function has to be continuous at that point. We cannot find derivatives at points where functions are discontinuous. However, a function may be continuous at a point and not have a derivative there. So just because a function is continuous does not imply that a derivative exists at that point. If the derivative exists, the function is continuous. If the function is continuous, a derivative still may or may not exist. And I think this sounds, me personally, I think this sounds pretty confusing in writing or in a verbal description, but I want to show you an image that kind of helps hit this home, I think. And this image is actually from your textbook. And here it is. So one of the things that the book points out is that a function fails to have a derivative at a point where the function is not defined, where the graph of the function has a sharp point, or where the graph has a vertical tangent line, okay? And so here in this graph, we can see we've got a sharp point at that first value of x1. There's a vertical asymptote there at x2, which means that we don't actually have a defined value of the function at x2. At x3, the function is not defined because we have two different endpoints of the graph and they each end in a hole. So there actually isn't a value of the function defined at x3. And then at x4, we have a case where the graph goes vertical. And so the tangent line would to the graph at that point would similarly be vertical. So what we're looking at here, if we look at the interval from x1 to x2, the function is continuous on that interval, and it's got a derivative at each point on that open interval from x1 to x2. However, if we look at the interval from 0 to x2, the function's continuous there, right? We could draw the entire graph without ever picking up our pen or pencil between 0 and x2. However, at that sharp point at x1, even though the function is continuous at that point, the derivative at that point does not exist. So hopefully that graphic helps that make a little bit more sense. And in the next video, we will be concluding this section.